5, 4, 3, 2, 1. Release. We are starting a new project, okay? Our last project, I guess you could call it project, was the spaceXcentric parachute documentary that I released on YouTube. Okay, but this one is going to be more involved. This isn't going to be a documentary released on YouTube. This is going to be a members-only series, summer series, all right? Because I expect to do this throughout the summer. It's not going to be done anytime soon. And what we're going to do is we're going to do a hands-on project of building an RC Skydiver, in case you didn't see that in the title of this video. All right, and you're probably asking yourself, why? And what is that? Well, let me explain to you my thinking, I guess you could call it logic. Maybe it's not logical. So I had a lot of fun with the parachute documentary. Thank you guys for recommending that. But before I even floated that, or we even talked about doing that, I floated the idea of possibly doing a video series on making an RC Skydiver. And a couple of you said, yeah, do that. So I was motivated to do it. Some of you were motivated to do it. That's enough for me. I'm going to do it. So that's one reason for you guys. A second reason is I've always loved RC toys. I grew up with them. When I was a kid, I flew RC planes, cars, motorcycles. I think the only RC thing I didn't really have was a boat, but I loved watching those too. And RC stands for radio controlled or remote controlled. I think it's more accurately radio controlled. And obviously I've always loved skydiving since I think the age of 4. When I first saw skydivers on TV, I was just fascinated by it. And I don't know why I'm such a weirdo and why I love parachutes so much, but I've always found, ever since I was like 4, the idea of gravity and a falling object deploying a series of events to open a parachute to save itself. It's such an awesome sight for me. And I think everyone has that one thing about them that fascinates them in life, and that is definitely mine. Maybe it's waterfalls for some people. I don't know. Maybe it's insects. I don't know. But for some reason, my bugaboo, the opposite of my bugaboo would be things deploying parachutes. I love watching it. And so when I was a kid, I'd always be out in the backyard sewing parachutes, throwing toys up in the air. And when I was in high school, my dad and I, we bought a little trainer RC plane. It wasn't really little. It had like a 4 or 5 foot wingspan, but it was big enough to hook a 12-inch action figure with a sewn parachute onto him on the bottom of the plane. And the idea was to static line deploy him from a certain altitude. It was what Peter Beck would say, a very passive system, because it wasn't radio controlled, only the plane was. But we never got it to work because he would end up shaking loose on takeoff because the ground would be so bumpy. And so my dad passed away in 2014, actually 2 days before my wedding. So I feel like this would be something cool as like a dedication video to him. Be like, listen, look, Dad, I'm 34 years old and I accomplished this now, and I made it more sophisticated. I'm hoping I can accomplish this. So that might be I guess that could be my second reason why I'm doing this. But I think the biggest and most important reason why I'm doing this is just because it's something new for me. I've never, even though I grew up playing with RC toys, I regret I never took them apart to play around with the innards. I never got my hands on the servos or anything, and I wish I would have. I feel like I would have learned so much more. And I'm surprised I never did, because as a kid, I was always fascinated with the hard sciences, what we would call hard science. Elon Musk would call it hard science. Some people would call it operational science. Here in the now, working hands-on on technology, that is definitely hard science. And I've always been fascinated with like that kind of stuff and electrical switches and circuits. And this is kind of the same thing, opening and closing a circuit, only it's radio waves instead of electricity and electrons. But anyway, I think this would be a great, though I'm 34 and I've done bigger things with my life. Like for example, for the first time, I'm about to replace an actual breaker in my house breaker box because one of them's not working. And I consider that a big deal for me because I'll probably end up electrocuting myself. But I'm about to try it as soon as it gets here in the mail. But this coming from the guy that's changed his brake pads once and made a vow that he'll never do it again. So I don't know how I got off on that tangent, but I feel like this is something I can learn a lot from. actually getting my hands dirty, even though it's a toy that I'm working on, and working with, even though we haven't even started this thing yet, I've already ordered the supplies. I had to do some research to know what it was I was going to order. So I've already learned so much just from what I've done so far. And I feel like if I can teach myself how to do this project and it's successful, I'll feel so accomplished. It's kind of like model rockets. You can build a model rocket kit because there are RC skydivers out there online. I think through like third party, just individuals that are making their own and selling them. You might not be able to find them anymore. Maybe they were a thing in the past. I don't know. I don't care. I want to build my own for the same reason that I build my own model rockets. You feel so much more pride and accomplishment and confidence in your abilities when you're done and if it works. So I feel like this will be a good challenge for me. So that's the most important reason why I'm doing this. I think it's going to be a challenge. I think I'm going to learn a lot because I've already have learned a lot and I haven't really started yet. I've just ordered the supplies. You can probably see it back here on the table behind me, some of it. And so we're going to talk about in this first video kind of the overall arcing plan. All right, how this I foresee this going, and what the plan's going to be. So when I was a teacher, I taught high school sciences and junior high or middle school sciences, whatever you want to call it. And one of the classes I taught was like the earliest engineering class you could basically take as a person, and that is 9th grade physical science. It's like a pre-engineering / chemistry class. And the first thing I would tell my kids when we would start on projects is that the first thing you need to do is you need to draw up blueprints. All right, it's very important to make sure you know where you're going with your project because things will inevitably change. You'll have to adjust things, and you want to keep organization, whether it's physical organization or organization in your mind. You want to keep it as clear as possible, and the way you do that is you start off by drawing out your idea on paper. And you can do it on a computer these days, but I guess I'm an old-fashioned 34-year-old. So this is our RC Skydiver, all right? And he's made of wood. Now, here's the thing. You do, like I said, you do blueprints because things will inevitably change. And guess what? I just drew these up earlier this week, and they've already changed, all right? What we're looking at here is a wooden Skydiver, all right? He's got his little helmet on. He's got his arms that have no hands, and he got his guts, all right? And what we have here are 2 servos. These are micro servos. I think they're about 9 grams each, connected to some actuating rods or control rods, whatever you call them, which are attached to the arms, which can move the arms up and down. Now that's very important because these arms are attached to the toggle lines, the steering lines on the parachute. All right, and these are their power cables running down to the receiver. Okay, so that's kind of like the brain of the Skydiver. That's in his hip, I guess, and it's also connected to a 6-volt battery. All right, which are basically 5 AA batteries. And it's in a hollowed out piece of block of wood, all right, basswood. And then you have his little legs here that are connected as well. Now this is like an inside view, a transparent view. He'll have a cover on his belly here. This is the belly view, all right? This is the visor on his helmet. And a few things have already changed, like I said. Like I found out a different way of making the arms hinge. I was thinking I'd use like a pin to do it, but after doing some research online and shopping to see what I could find, I found some different I don't remember what they're called, but they'll work, and I'll show you in a later video what those are. So this design part has already changed, and this whole thing will probably end up being shorter. This is not to scale, but this is about 6 inches in real life. This block is 6 inches long for the main body, but it'll probably end up being like 2/3 of that. I'm gonna make it as compact as possible because weight is a thing, and we'll talk about that here in a second. So we go to the back view of the blueprints here. So this is his back looking down on him. You can see his container right here. Right, these are the lines again connected to his hands. And so the idea is to deploy a drogue chute / pilot chute from the lower part of the container here. All right, and we do that using a third servo, which is another 1.5 gram servo, which upon upon a switch of the transmitter in my hand or remote control, it releases it and stabilizes the guy before deploying the main. So the pilot brittle is connected to the closing mechanism for the main chute container, and which is connected to another 1.5 gram servo. Here's the power line running down the side and into the guy's body. Now, again, changes have already happened. I was thinking about this last night. I was like, this is gonna these closing rings will be connected to it's nylon material. Now it could be reinforced with cardboard on the inside, but regardless of all that, it's gonna be more flexible and susceptible to movement. So a pin probably won't be the best way of closing it this way. They'll probably slip off the pin and move. So I was thinking, well, how can I fix this issue before I even get started? Because I know I'm going to run into this issue, and I would hate to build something this time consuming only to have to change it while I'm doing it. And I thought, well, my sea bag from the Navy closes by sticking a metal rod through these 3 loops. And I was like, wait a minute, that's actually how a real skydiving container closes. If you watch my parachute documentary the other week, that's how they really close. And for my parachute days, I was like, oh yeah, I remember doing that. So I was like, why don't I just do it that way? That way it makes a lot more sense. So this has already changed. I will have a loop sticking through 3 or 4 metal rings and a loop sticking through, and then the rod will stick through that loop and deploy the main. So the pilot chute or drogue chute will come out, and it won't directly deploy the main chute because it will be hooked into this little closing system here. It will rely on this servo to release the bridle of that pilot chute, which will then pull out the main once that's released. And the reason for doing that is to basically stabilize the RC Skydiver before we deploy the main out, so the main doesn't get tangled up in his arms or in the legs, or even just in itself get like I forget what the actual malfunction is called, but it's when part of your parachute goes through a line and causes it to tangle. So that's the idea anyway. Again, things are going to change. I've done these kind of projects before, nothing like an RC Skydiver, but just these kind of little hands-on projects. You have these ideas in mind, but as long as you go into it knowing that you're going to have to be flexible because you're going to encounter problems you never foreseen, like Elon and his Starship, all the problems he's encountering, you got to adapt, you got to overcome. That's what engineering is all about. So now the question becomes, well, how are we deploying the Skydiver? Are we just tossing him up in the air? Are we throwing him off a cliff? Well, you could base jump him, I guess, but no, what we're going to do is we're going to attach him to the bottom of my drone. All right. Why not? I got a DJI Mavic 2 Pro. It's a really powerful drone, and the best part is it has a 4K camera right on board, so you can get that top-down view as he's falling away, which is pretty sweet. So this is how we're going to attach or mount the RC Skydiver to the bottom of the drone. All right, here's the camera right here. It's looking to the right over here, so it's a side view, and we have a box that we connect to the fan rods or legs or whatever you call them that the propellers are mounted on, and we'll do that using like a Velcro material just connected to some like lightweight wooden rods that hang down from it, all 4 of them. And then I've already changed this a little bit. We'll no longer make it like a box kind of thing. This will be open on top, and so the parachute will be smashed up against the bottom of the drone. Again, that's just to save weight. We'll talk more about that here in a little bit. So anyway, you might have noticed in this previous belly blueprint, we had this 3rd small actuator we talked about, or I keep calling them actuators, or servos. That's another 1.5 gram servo. This one's for the release of the mount. So this is it right here. Here's another view from the bottom. Each mount door that's going to keep the Skydiver attached to the drone will have like these little rings sticking out of them. I already ordered these. I already know what they look like. Another pin going through it. So we actuate this servo, which pulls the pin through these door ring rod things, and they open up. All right, let gravity do its thing. So that's this right here. So when you transmit the signal through the transmitter, it hits the receiver, it actuates this servo to pull the rod this way, releasing him. So that's the idea anyway. All right. And then again, we can point the camera straight down so we can get a good view of the Skydiver falling away. So we'll no longer have a top portion of this box. The ends will be open. So really it's just going to be, we'll have panels on the side to make sure he stays in there nice and snug, and then doors on the bottom. And I realize how crappy this drawing is. I'm not an artiste. So that's the idea. That's the basic overview of what I want to happen, what I'm aiming for. Things will be changed. Things will be adjusted as needed. So in order to make this happen with the drone, I had to answer some questions before I really got started in buying stuff. And the first question was, my drone has sensors on the bottom of it, so it knows how far it is from the ground, its altitude and everything. I don't know if it has a barometer in it. Maybe it does have a barometer in it, but I know that it has sensors on every side of it, the front, the back, the sides, and the bottom, so it knows if there's any obstacles around. So I wanted to know if it would still fly if those were covered up. So what I did was I took my drone and I covered up the sensors on the bottom, because that's where the parachute guy is going to be stuffed up against there. So they won't be able to use those. These are just like searchlights or spotlights or whatever. And so anyway, I taped them up. I took it outside and I flew it, and it did fly. It worked well. You could tell that it was a little bit less stable, like not less stable, but it kind of wanted to move up and down slightly more than it normally would have, just because I don't think it had a relative position to the ground, but it still worked. So that was the important thing. So that was the first test. I want to make sure I could actually do this with my drone, because if I built this RC Skydiver and realized, oh, the drone's not going to work with him, then what the heck am I going to do with him? Stand on my roof, throw him off my roof? Anyway, so the next test I had to do to make sure this would work was find out how much weight the drone could lift into the air. All right, because that's very important. If I build the Skydiver too heavy only to realize, oh, my drone can't even take him off the ground, then what am I going to do? So I was like, well, I'll go ahead and do a physical test of this, take it outside, see how much it can weigh. And I was like, I bet someone else has already done this. And so I YouTubed it, and yeah, surely enough, I came across like at least 5 videos of people doing this test, where they would take their drone, put some weights under it, and keep adding and taking away weight to see how much it could deadlift off the ground. And what I came to was that it averaged out to be about 2.3 pounds of weight that it could lift, sometimes more, sometimes less. So between 2 and 2.5 pounds, this drone, the DJI Mavic 2 Pro, could actually lift off the ground. And so what I decided to do was make it an even 2. So as long as my drone can get 2 pounds off the ground, I'll be all right. So I'm going to try to build my Skydiver with the mount included all under 2 pounds. So I got a little video I'm going to show you of that right now. All right, guys, so the max weight that my DJI Mavic 2 Pro drone can lift is between 2 and 2.5 pounds. It's actually more like 2.3 pounds from what I've researched. Okay, so what we're going to do today is kind of find out how much wiggle room I have to work with when I build this thing. Now, obviously, I haven't built or carved or done anything with the RC Skydiver yet. We're still in the preliminary kind of just get the supply stage. So none of the supplies I do have is cut or hollowed out yet. So everything weighs more than what it's really going to weigh. Parachute's not made yet. This is all the material. Obviously, I won't use all of this. Won't use all the wood. I'm not going to be using these bags that the receiver here is in or the servos are in. So this is a very rough estimate. Okay, so we're going to turn on this scale and see exactly how much 2 pounds is in this kind of supplies. So this is where I start to get scared to see how much weight I'm going to have to cut from my design plans. This block is heavy. This is not balsa wood. This is basswood. This is like real carving wood. So let's see. The scale's set to pounds and ounces, so we're at 1 pound, 0.2 ounces. Okay, we've already used up half of our weight, which is great. Not really. That's not that great. Now the good news is I am only going to use about half this block. I'll cut it in half, and then I'll use only half of it and hollow out that half to make room for the animatronics or whatever. So that's a good thing. But I'm also going to weigh these 2 blocks because I'll need these for like the release mount that attaches to the drone, also the arms and legs and head and whatnot for the Skydiver himself. So let's see how much this will weigh. Okay, we're still at about a little less than 1.5 pounds, so we still have some room to work. This might be a good thing. I thought we'd be over 2 pounds by now, to be honest. Let's try the parachute material. I can't see. Put it up here. Stay. All right, we're at 1 pound, 11 ounces in it, sliding. Cripes. There we go. No, it's not cooperating. All right, 1 pound, 11 ounces. We have about 4 more ounces to work with. Let's do these not actuators, these servos. Stay. And we're at 1 pound, 13 ounces, 13 and a half ounces. This battery is pretty heavy. It's 5 AA batteries. So let's see where I can put this thing. Oops. And we are over 2 pounds, 2 pounds, 2.5 ounces. You know what? I'm actually feeling really good about this. All right. Like I said, we have about 2 to 2.5 pounds to work with. We're about right there. We're a little less than 2.5 pounds. And obviously I'm not going to use a lot of this, like the baggage and stuff. And I might end up using more blocks. So let me add these too. I don't know how I'm going to do this. Just to see what I can get away with. Again, I'm not going to be using, I'll be carving these blocks. I'll be hollowing out some blocks. I'll also be using nails and pins and stuff. So it's going to be give or take, give and take. Now we're at 2 pounds, 9.5 ounces. So yeah, I'm feeling really good. I feel so much better now that I actually did this. Basically, I know I can build the thing how I want, as big as I want, as long as I'm conservative when it comes to, you know, carving out the wood and using the wood. I think I'll be all right. This is a very good thing, guys. But yeah, guys, that's it for this first video. I think I spoke enough about it. Just giving you a brief overview of what's to come. This will probably be like a 10, maybe 11 episode series throughout the summer. The thing is about me is once I start a project, I like to focus all my energy on it. So who knows, I might get this done in a month. But the idea is to work on it sparingly a couple times a week, get you a video out, at least maybe one video a week. And the next video I'll release is on the electronics of it. I already got my transmitter receiver, my battery pack. I got my servos, just waiting on the batteries, which I think are arriving later today. So I'll probably release that video in a few days. Got a lot of testing to do with these electronics, a lot of things to figure out. So it's going to be fun, guys. I hope you join me for this little adventure and maybe learn some stuff as well. Until the next one, Godspeed.